Hello, everyone. So, if you're just getting started in research, you're probably wrestling with a few really big questions, right? How in the world do I collect data the right way? Once I have it, what do I even do with it? And, of course, the big one, how do I choose the right statistical test? It can feel like a lot, I get it, but don't worry, we're going to break it all down step by step.
Ah, yes. This is the question that probably keeps a lot of new researchers up at night. You imagine you have to memorize these giant, complicated flowcharts just to survive. But what if I told you it's not about memorization at all? It's really just about learning to ask a few simple, logical questions. And that brings us to the single most important idea in this entire explainer. It's a real game changer. See, most people think the whole statistics part of research doesn't even begin until you have a spreadsheet crammed with data. But the truth is, a really good analysis, it starts way, way before that. It actually starts the moment you begin to plan your study. So, to get you from feeling a little lost to feeling totally confident, here's our game plan. We're going to start with the absolute bedrock, your research question. From there, we'll talk about planning your data collection, handling it like a pro, and then, only then, will we tackle choosing the right test. We'll wrap it all up with some practical examples and a checklist to keep you on the right track.
Okay, first things first. Before you even think about opening a spreadsheet, you have to be absolutely crystal clear on one thing. What is the exact question you are trying to answer? This isn't just some formality you check off a list. It is the foundation for everything else you're about to do.
So think of your research study like a little play with three main characters. First, you've got your outcome variable. This is the star of the show, the thing you're actually measuring, like, say, blood pressure. Then you have the predictor or exposure variable. This is what you think is causing a change, like a new drug. But then you have the confounders. These are the sneaky side characters, like age or lifestyle, that can get in the way and totally mess with your results. And here's the key. If you don't identify them right at the start, you can't account for them later on.
Next up, you got to know what flavor your data is. Is it nominal, which is just categories with no order, like blood types? Is it ordinal, where there's a clear order, like mild, moderate, or severe? Maybe it's continuous, a precise measurement, like height or weight. Or it could be count data, like the number of hospital admissions. This might seem a little academic, but trust me, knowing your data type is critical because it directly points you to the right statistical test later.
All right, so you've got your question, you know your variables. Now it's time to actually go out and collect that data. And this can't be a casual thing. You need a system, a standardized process, to make sure every single piece of data you get is clean and reliable from the get-go. Before you even talk to your first participant, you need solid answers to these questions. Who exactly is in this study and who is out? At what specific point in time will you collect the data? What exact tool will you use? And crucially, what are the units? Are we measuring weight in kilograms or pounds? Is age in years or months? Getting this stuff standardized from the very beginning will save you a world of hurt later. And please, I'm begging you, whatever you do, do not skip this next step, pilot testing. Taking your questionnaire for a test drive with a few people isn't just a good idea, it is absolutely essential. This is your one chance to find those confusing questions or realize you forgot to ask for a key piece of information before you've collected 200 surveys. Trust me, it's so much easier to fix one form than to clean up 200 messy data entries. And let's not forget, good data collection isn't just about getting numbers on a page, it's about people. It's about earning their trust. That means getting proper informed consent, fiercely protecting their privacy, and making sure everyone on your team is trained to collect data in the exact same way. That's what makes your final results both ethical and believable.
Okay, you did it. You collected all your data. You can kick back and relax now, right? Well, not quite. This next phase, how you handle and organize that raw data, is absolutely critical. Getting this right is how you prevent massive headaches before you even start your analysis.
The whole process can really be broken down into these 6 straightforward steps. You're going to create your data sheet, code everything consistently, hunt for any errors, clean up the mess, figure out a plan for missing data, and then store it all somewhere safe. But let's zoom in on the one tool that makes all of this possible. And that brings us to the codebook. Seriously, think of this as the user manual for your data. It clearly defines every single variable, explains what the codes mean, like 1 equals male, 2 equals female, and lists the units used. I'm not exaggerating when I say that a well-kept codebook is the single most important thing standing between you and a completely confusing, unusable mess of data. And now, the moment you've been waiting for. We are going to figure out how to choose that statistical test. But forget about memorizing a giant, scary table. Instead, we're going to approach this as a logical decision-making process, like a simple decision tree you can walk through every single time. These 5 questions right here are your secret weapon. First, what's my objective? Am I comparing groups or am I looking for a relationship? Second, what's my outcome variable's data type? Is it continuous or categorical? Third, how many groups are there? Fourth, are the observations independent or are they paired, like a before and after measurement on the same person? And finally, if the data is continuous, is its distribution normal or skewed? Answering these questions will narrow down your choices almost instantly. Let's see this in action. Say you want to compare the average hemoglobin level between a treatment group and a control group. Let's walk through our questions. Our objective? Comparing groups. Our outcome? Continuous. How many groups? 2, and they are independent of each other. The very last question is about the data's shape. If it's normally distributed, like a nice bell curve, you use an independent t-test. If it's all skewed to one side, you use a Mann-Whitney U-test. See? No memorization, just pure logic. Let's do another one. This time, you're measuring a patient's blood pressure before and after they receive a treatment. Okay, this time the data is paired, right? It's the same person measured twice. So again, you just check the distribution. If it's normal, you go with a paired t-test. If it's skewed, you use the Wilcoxon signed rank test. The same logical framework guides you right to the correct answer every time. Okay, now that you've got the basic framework down, let's really build up your confidence with a couple of quick, rapid-fire examples. This is going to help make all these concepts really stick. All right, it's your turn. Imagine your goal is to compare the cure rate, so the proportion of people cured, across 3 different drugs. What test are you reaching for? Just think through those questions. What's your objective? What's your data type? How many groups? The logical choice here is a chi-square test. And why is that? Well, because you're working with a categorical outcome. Either they were cured or they weren't, and you're comparing more than 2 independent groups. The logic leads you straight to it. But remember this, choosing the right test is really just the beginning. A truly great analysis doesn't just stop and shout, "The p-value is significant." A great analysis asks the more important questions, like, how big was the effect really? And is that difference actually meaningful in the real world? Never, ever forget that statistical significance is not the same thing as practical importance. All right, let's bring all of this home. We're going to wrap everything up with a simple workflow and a checklist you can use to guide your own research, from the very first idea to the final analysis. Think of this slide as your guide to what not to do. These are the most common traps researchers fall into. Collecting data with no real plan, not bothering to make a codebook, ignoring missing values, and focusing only on that p-value. Seriously, if you can just avoid these common mistakes, your research is going to be miles ahead of the curve. So if you only take one single thing away from our time together, let it be this. Good statistics is not a memory test. It's a way of thinking clearly. Always bring it back to those fundamental questions. What am I trying to ask? What kind of data am I working with? And what am I comparing? If you can answer those, you'll find the path forward is a whole lot clearer. You'll turn what seems like a daunting task into a logical and maybe even exciting journey of discovery.